Hello students, welcome back to the next session in units and measurements. In this class, we are going to study about dimensional analysis. Yes, what is a dimensional analysis and how much this dimensional analysis is important? Yeah, here I brought the proof also how much it is important. Every year there is a compulsory 1 or 2 questions in JEE Mains examination and as well as JEE Advanced examination and also in NEET examination. There is a guarantee question from this particular chapter. Yes, sorry, particular topic, dimensional analysis. In earlier class, we have seen that what is a dimension. Yeah, what is a dimension? A dimension is nothing but represent the dimension. To represent any physical quantity, we can raise its power to represent that particular physical quantity. We have given the dimension for the basic physical quantities like mass, length and time. And also we have given for 7 fundamental physical quantities and also given for derived physical quantities. Yes, in this class we will discuss the dimensional analysis and its application and where it is useful. Yeah, we have seen some physical quantities are having dimensions and some physical quantities are not having dimension. Example, we have seen a plane angle and as well as a solid angle. Plane angle and solid angle not having the dimensions. So there is no dimension. That means those physical quantities we can say that dimensionless physical quantities. Some physical quantities having dimensions but those are constants, so that's we can call dimensional constants. Yeah, we will start with the dimensional constant. What are the quantities? What are the dimensional constants? Dimensional constants. Yes, you know universal gravitation constant, gravitational constant, Planck's constant. Planck's constant we can get in case of energy consideration. Planck's constant, universal gravitation constant, coefficient of viscosity, that is also a constant function. Boltzmann constant. So this kind of universal gas constant. So this kind of components are called dimensional constant. Dimensional constants. And some functions we have dimensionless. Dimensionless. Dimensionless quantities. So what are those dimensionless quantities? The dimensionless quantities are like angle, solid angle and as well as plane angle. And also you know that refractive index we can give as a dimension. Coefficient of friction also a dimensionless quantity. And strain also a dimensionless quantities. Yes, what are the advantages of this dimensional analysis? Yeah, here some advantages or applications are given here. So those are we can convert one system of unit to the another system of unit. One system of unit we can convert it into another system of unit in case of by using of dimensional analysis. We can check the correctness of the equation. whether the equation is correct or not, we can check by using of this dimensional analysis. And we can derive the relation among the different physical quantities. We can give the relation between different physical quantities and the principle of homogeneity. Yes, we can see what are these all things, what are these all applications, and based on every application we will try to solve a simple question which is given in previous year's examinations. Yeah, let's start. So first we'll go with the how we can able to convert one system to the another system. The first one system to another system. We know that we can able to write when we are writing a unit, we mention as unit is a standard measurement, and we write it is n into u is equal to a constant. N into u is equal to constant. N represents the numerical value, u represents the unit, and as well as we can write if n1 u1 is equal to n2 u2. That means we can able to take from one system to another system. Yeah, we can how to solve, very simple, it is one system to another system. For example, I have a function in one system like the first, already I have given a small example, 1 meter equal to how many centimeters type. Yeah, here for example, if they are giving in one system, given system n1 and its units given, we can consider m1 power a, l1 power b, t1 power c. In another unit, the value is m2 power a, l2 power b, and t2 power c. What is the value of n2? What is the value of n2? N2 value we have to calculate. For that, I can write the equation n1 u1 is equal to n2 u2. The value of n2 is equal to, you can write n1 u1 by u2. Simple. Let's put the value of u1 u2. That means I can get the value of n2 is equal to n1 of u1 m1 u2 by m2. We can write whole power a, and l1 by l2 whole power b, t1 by t2 whole power c. Yeah, like that we can able to write n2 is n2 value n1 m1 by m2 whole power a, l1 by l2 whole power b, t1 by t2 whole power c. Yes, exactly. So what is this ABC? ABC are the values to represent their power, dimensional power. Yeah, this is just how to we can able to write a system from one system to another system. One system to we are converting to another system. Another system. Yes, now we can take a small example, one question. We take a known function only. They gave a force unit in SI system, in SI unit. We have to convert to CGS. We know that force in SI unit is nothing but, for example, if they are giving Newton, 1 Newton is equal to how many dynes? 1 Newton is equal to how many dyne? That is the question. Yeah, I think most of the people you must have know that what is 1 Newton, but we are going to solve by using of dimensional analysis. Yeah, right. So here this equation in the form of N1 U1 is equal to N2 U2, right? That means the value of N1 is equal to, I can write numerical value 1, and the value of U1 is equal to, you can write, what is the dimensional formula of force? M1 L1 T minus 2, M1 L1 T minus 2. But here in SI unit, they said 1 Newton, nothing but mass we can measure in case of SI unit kg, nothing but the value of M1 is equal to kg. The value of L1 is equal to 1 meter. The value of T1 is equal to 1 second. Yeah, similarly, what is N2 actually we have to calculate. For that, we can take the value of U2. U2 also dimensionally same. M2 power 1, L2 power 1, T2 power minus 2. But what are the values of M1, M2 and M2, L2, T2? Yeah, here I am considering M2 in which unit mass? CGS. Mass we can take in grams. Length we can take in centimeter. Time we can take in seconds only. So mass grams, length centimeter, time in seconds. Yeah, we will write that. N2 is equal to, what is the formula we mentioned? N1 of M1 by M2. Actually here power A, if you are writing the value of A, B, C in previous we wrote A, B, C. A is equal to 1, B is equal to 1, C is equal to minus 2. If you are writing that M power 1, this means M1 by M2 whole power 1, L1 by L2 whole power 1, T1 by T2 whole power minus 2. Let's put the values. N1 is equal to 1 we have. M1 is equal to 1 kg. I am going to convert into gram. 1 kg is equal to how many grams? 1000 grams. And M2 in grams, gram only, whole power 1. Length 1 meter. 1 meter equal how many centimeter? 100 centimeter by L2 1 centimeter whole power 1. Time again 1 second by 1 second whole power minus 2. That means the value of N2 you got 1 into gram cancel, centimeter cancel. Remember N2 is just a numerical value, right? Yes. So 1 into 1000 into 100. This is 1 lakh or 10 power 5. And finally, what we have proved that the force 1 Newton is equal to 1 Newton, which is equal to 10 power 5 dyne. Yes, this we can also able to calculate by using of another condition. But why it is important? Why it is important? Jay, akkada book undi na. 2 books పెట్టచ్చు తొందరగా చిన్న book. Yeah, here we will prove why it is important. We will solve one previous years of question based on this formula. Yeah, the question is given in 2019 JEE examination. The question is the physical quantity in SI unit. Sorry, the density of the material is 128. Yeah, let's see here the question which is given in JEE 2020, JEE 2019. The density of material is given 128 kg per meter cube in certain system of unit, means some other system of unit. The length is 25 centimeter and mass is 50 grams. Find the numerical value in that new system. What is that new system? We don't know. In that system, we have to calculate the numerical value. Yes. For that, we can write in the first given unit. Given obviously you can see kg meter cube is MKS or SI system. So I can write here N1 U1 is equal to simply N2 U2. The value of N2 is N1 of U1 by U2. That is actually we have to calculate, right? So see what is N1? N1 is equal to 128, no doubt at all, 128, right? What is U1? U1 given kg, unit given per meter cube, means mass and as well as length given. So that is nothing but I can take M1 L1 power minus 3 because L cube na, L1 power minus 3, and N2 actually you have to calculate. Yeah, in this M1 is equal to, they said M1 is equal to 1 kg and L1 is equal to 1 meter cube. L1 is equal to 1 meter cube, means you can write 1 meter, no problem, right? Next, U2. U2 also, U2 they said centimeters and as well as grams. So M2 power 1, L2 power minus 3 only. Yes, exactly. The value of M2, 50 grams, given value, right? And L2 is 25 centimeters, right? That we can substitute in the given formula and simplify. We will get the value of N2. Yes, let's solve. N2. N1 is 128 by M1, 1 kg by 50 grams whole power 1. Next, 1 meter by 25 centimeter whole power minus 3. Yeah, we have to convert that kgs to grams, meter to centimeter. Yeah, let me see. N2 is equal to 128. This is 1000 grams by 50 gram whole power 1. 1 meter means 1000. Sorry. 1 meter 100. 100 by 25 whole power minus 3. Yeah, in simplification, GG cancel. This is a 20. Here centimeter cancel, and this is a 4. Right? Yes, so 128 into 20, 4 power 1 by 3 means a 4 cube. What is the value of 4 cube? You know that. Yes, exactly, 64. 128 into 20, 1 by 64. 4 fours are 16, 16 fours are 64, and it can be 2 times the value of N2 is equal to 40. Yes, this is the question. See what we have seen. We can convert from one system to another system by using of this, right? Yeah, this is the first case. And second application, we said that we can check the correctness of dimensional equation. We can check the correctness, and before that we'll see principle of homogeneity. Principle of homogeneity, because in principle of homogeneity only we can correct the equation also, right? Yes, principle of homogeneity, what is that? Very simple. For example, I have a function a is equal to x plus y minus z. A is equal to x plus y minus z. It's an equation. In this equation, you can see there is subtraction and as well as addition. But here the main rule, the dimensional formula of A, dimensional formula of A is equal to the dimensional formula of X. Yes, exactly. Which is equal to dimensional formula of Y. Yes, which is equal to dimensional formula of Z. That means here what are the dimensions of A? That is equal to dimensions of X. What are the dimensions of X? Which is equal to dimension of Y, dimension of Z. Means in an equation, if any two physical quantities are adding or subtracting, the dimensional of that physical quantities must be equal. Yes, that is the intention of this. Yeah, for example, we can see a small equation. You know that the equation, famous equation, S is equal to ut plus half at square. But here I am going to write the different expression. S is equal to at plus bt square. Okay, given equation, S is equal to at plus bt square, where S and T are, S is a displacement and T for time. You have to calculate, find the dimension of A and B. Yes, that is the question. We have to calculate the dimension of A and B. Yeah, let's see. Yeah. So displacement, S is a displacement, T is a time. Nothing but given equation. The dimension of S is must be equal to dimension of AT. Here A and T both are separating or both are multiplied each other, but that is a single term you should consider. Yeah, what is the dimension of displacement? We know that m0 L1 T0, this is the dimension of displacement, and dimension of AT. A we want actually, T for time, nothing but T1. Now means m0 L0 T1. But we want the dimension of A. Dimension of A is equal to simply L1 by T1. That means L1 T minus 1. This is the dimension of A. Right? Yes, exactly. And similarly, dimension of S is equal to, yes, in this what we have the term, yeah, dimension of bt square. Dimension of S is equal to dimension of bt square. Dimension of S again L1. B we want t square. That means the dimension of B is equal to L1 by t square. That means L1 t minus 2. L1 t minus 2. So like that we can able to write by using of principle of homogeneity. Yes, we can see one more example. If I have a function, a different function we will take with angle something if they are giving. So that's we will see. If I have a function, let's consider y is equal to a sine bx plus kt, bx plus kt, like that something equation. Yeah, what is the thing, you know that here it is a given function. Yes, in this you can consider sine of something. This something must be angle, right? Yes, of course. That something is must be angle, because we can write y is equal to something a into sine theta. Theta is angle. Yes, nothing but here the dimension of angle, nothing means sine theta dimensionless. But A must have the dimensions. For example, here they give y is a displacement. Y is displacement. Y is a displacement. So, and sine theta is dimensionless. Dimensionless, because angle is a dimensionless. So here what you can able to find, if they may ask, find the dimension of A, capital A, B, K. So they may ask like that, A, B, K dimensions they may ask. So very simple, y is a displacement. So a dimension is equal to y dimension. Exactly. The dimension of y is equal to a dimension of a. Dimension of y. Y is nothing but L1. So that's why dimension of a is equal to simply L1. Right? And we said that already bx plus kt is equal to dimensionless, nothing but m0 l0, right? That means bx dimension is equal to nothing m0 l0 t0, nothing but the dimension of b is equal to 1 by x. Here x and y are displacements. X is a displacement. That means its dimension is L minus 1. Right now, the value of B is L minus 1. Understood here? Bx equal to m0, l0, t0, because it is a dimensionless. Then x is equal to, B is equal to 1 by x. X, 1 by x is nothing but L power minus 1. Yes, exactly. Similarly, kt also dimensionless, right? Kt also dimensionless. M0, L0, T0. The dimension of K is equal to 1 by T. T for time actually. That means a T minus 1. T minus 1. Hope you understand. Yeah. We can see one small question which is given in previous year of exam. Yeah. See the question? Force is given in terms of time displacement by the equation F is equal to A cos bx plus C sin dt. A cos bx and C sin dt. That means F dimension is equal to A dimension. A cos bx c sine dt, right? So here cos of something angle, sine of something angle, means first you can get the dimension of b. Oh, first of all, see, f is a force, so here angle, so that's why dimension of f must be equal to dimension of a. Yes or no? Yes, dimension of f is equal to dimension of a is equal to dimension of c, because it is also separated with plus, right now. Yes, what is the dimension of f? m1 l1 t minus 2. This is only dimension of a. I think in this question no need of c, right? So a dimension we got. What about B and D dimensions? Yes. So already I told B and here cos of Bx is angle. So angle is a dimensionless. Bx is M0, L0, T0. Right. So the value of B dimension is 1 by x. X is a displacement. So that's why L power minus 1. B dimension L power minus 1. See, dt is equal to m0 l0 t0, nothing but the dimension of d is equal to 1 by t, that is nothing but t power minus 1. See, we got a b d. Let's a b d, a b d, a b d, you know that a b d, yeah, a b d Villiers. Yes, a m1 l1 t minus 2, d t minus 1, and this is b t power minus 1, l power minus 1. So let's take 2 here. So then this will becomes m1 L2 T minus 3. Which option you can see? M1 L2 T minus 3. See, 3 and 4 you appear to be similar but not. 3 and 4 you appear to be similar but not. Fourth is the correct answer. M1 L2 T minus 4. So option 4 is correct. Yes? Yeah. Next, get back to our concept. Principle of homogeneity completed, and we have seen the question also based on that. And one more question we can see, which is given here as a function, different system. Yes, if they are giving the function velocity v, time t, force f is chosen as a base physical quantities, and you have to calculate the dimensions of mass. Yeah, this is the question given to us. Very simple question. Yeah, so what they have given, velocity given, the velocity dimensions v is equal to, we can write L1 t minus 1, but here you can see in options how it will be. It is in terms of like something in terms of ftv, yeah. So that's why what we can consider here, the mass, actually we need the dimension of mass. We can consider dimensions of mass is directly proportional to, we can take f power x, or else you can take v power x. V is a first quantity, v power x, t power y, and f power z. Means mass is in terms of v, t, and f, velocity, time, and as well as force. So we have to derive the dimensional formula of mass. Easy question. Yeah. So mass dimensions is V power x, V power y, T power y and F power z. First we will write the dimension of this. Dimension of velocity. Velocity dimension L1 T minus 1. Time dimension T1, 1 only. And force dimension M1 L1 T minus 2. Let's put wherever they have given that. That means mass directly proportional to V power x. What is the dimension of V? L1 T minus 1 whole power x, right? Next, T power y, that's all, nothing is there. Time. Force F, M1 L1 T minus 2. T minus 2 whole power z. Okay, you know that what is the dimension, what is the directly proportional means almost equal. We know that what is the dimension of mass. Mass dimension M1 L0 T0, which is equal to, see, L power x, L power 1 into x, x, L power minus 1 into x minus x, T power y, M power z, L power z, T power minus 2z, right? Yeah, if bases are equal, then we can write the power. See, M1 L0 T0 is equal to L power x and one more L term we have here. See, L power x plus L power z. That means L power x plus z, right now? And time you can see T power minus x plus y minus 2z, right? LT completed. Remaining what we have? M power z. Okay, let's equate this equation. If you equate it, see, M power 1 equal to M power z. If bases are equal, then powers also equal. Nothing but here the value of z is equal to 1. L power 0 equal to L power x plus z. Nothing but x plus z is equal to 0. That means z is equal to 1, x equal to minus 1. Did you got? Yes, of course. Easy na? Very easy dimensional analysis. See, this question given in JEE Mains 2021. So, x equal to minus 1. Now, x value you have, z value you have. Then you have to find the value of y. See, what is the equation given? Minus x plus y minus 2z equal to 0. X minus 1, minus of minus plus 1. Y 2, z equal to 1, 2 is equal to 0. 2 into 1, 2. Nothing but y value also 1 you have. See, x value minus 1. Y value 1, z value 1. That means what will be the equation given question? Yes, see, x is 1, sorry, x is minus 1, that is v power minus 1, f power 1, t power 1, v power minus 1. Which option? f1, t1, v power minus 1. Yes, fourth option. Yeah, last question also we got same fourth option. Right? So you have seen the two questions which are given in previous year JEE Mains. Yeah. So we have seen two methods: principle of homogeneity and conversion to the new system. And third one, to identify the unknown. Actually, now whatever we have solved, that comes under conversion of these, and as well as to determine the unknown equation, or it is a correctness of the equation also we have done, and relation between the different quantities also we have done, right? Yes. So we can see one more problem which is given in advanced examination. Yes. Yeah. See the question. The question, it is feeling little lengthy. Yeah, we have seen one more question which is given in JEE Mains 2019. Yeah, you can't believe the same question given in 2020 Mains, 2021 Advanced. Same question, but just they have changed a little bit. Yeah, see. What is the question? The expression for time in terms of G, universal gravitation constant, H, Planck's constant, speed of light. Speed of light. So we have to identify the dimensions of time. They may ask time, length, and mass. Yeah, in 3 different years they have asked the 3 different things. So here what I am going to do, I'm going to solve the time and I'm going to give the homework as, yes, mass and length. Let's see, they said time dimension you should write in terms of GHC. So that's why I'm writing time for T directly proportional to, like previous method, G power X, H power Y, C power Z type. Okay, G power X, H power Y, C power Z. So already they said G is universal gravitation constant. We can write the first dimensions of that. We know that force F equal to G m1 m2 by r square. Force, mass and distance. Yeah, let's write dimension of force m1 l1 t minus 2, dimension of G, dimension of mass m square, because m1 m2 are masses mass, so that's why m square and l square, nothing but the dimension of G is equal, you can see m1 here, m2 nothing but m power minus 1, because 1 and this is your 2, so 1 cancel, remaining minus 1, and it comes L cube, because L square into L1, L cube T minus 2. So this is the dimension of G. G dimension we got m minus 1, L cube T minus 2, right? And we can see the dimension of Planck's constant H dimension, but generally where we can get, yes, we can get in Planck's equation, energy E is equal to H nu. Planck's constant, Planck's equation, energy equation. It's like quantum theory of radiation, light, yes. So nu is frequency. Frequency is reciprocal of time. So frequency dimension is T power minus 1. Energy dimension, M1, L2, T minus 2. Now we need the Planck's constant, H is equal to, yeah, you can write E by nu, M1, L2, T minus 2 by T minus 1, nothing but M1, L2, T minus 1. It's a dimension of Planck's constant. H, G we got, G dimension we got, and H dimension we got, right? Next, C, speed of light. Array, we know that na, L1 T minus 1, right? Yes, we know that. Now I am going to put in this expression. Very easy question. Yeah, let's see. We have T power, T is directly proportional to G power X, H power Y, C power Z. Yeah, which is G M1 minus 1 L cube T minus 2 whole power minus X, H M1 L2 T minus 1 whole power Y, and C L1 T minus 1 whole power Z, whole power Z. Yeah, we'll make it little faster. Video getting lengthy. Yes, dimension of time dimension, you know that T1. Let's see, m power minus x, and here I have m power y, so that's why I'm writing m power x plus y. L I have here L power 3x plus L power 2y plus L power z, and time we have t power minus 2x, t power minus y, t power z, right? So by that you can see here m0 l0 you have, so minus x plus y is equal to 0, that means x is equal to y, and here 3x plus 2y plus z is equal to 0, x is equal to y, nothing but 5x plus z is equal to 0, right? Next, my x 2x minus y minus z is equal to 1. Yeah, x is equal to y, that means minus 3x minus z is equal to 1, because y is equal to minus. Yeah, I can write x minus 3x minus z is equal to 1, nothing but 2x is equal to 1, x is equal to 1 by 2. X is equal to 1 by 2, then z is equal to, means minus 3 by 2 minus z is equal to 1, that means z is equal to minus 5 by 2, okay, and y is equal to 1 by 2, nothing but the equation could be t is directly proportional to g power 1 by 2 h power 1 by 2 c power minus 5 by 2. Yeah, this is only they wrote like this, g h by c power 5 whole power 1 by 5 whole power root g h c power 5 g h c power 5. Which option? Option 1. Option 1 we have, right? Yes, in this Young's modulus, and in terms of different quantities, and given the same g gravitational constant, h Planck's constant, c speed of light, so asking for dimensions of y is Young's modulus. This question given JEE Advanced 2023 paper 2. Yeah, so already we know that the dimension of g, what is the dimension of g? We wrote m power uh, minus 1 L cube and t power minus 2. 1 minute, because important na. Yes, minus 2 t power minus 2, and then this is m1 L2 t power minus 1, m1 L2 t power minus 1, and dimension of c, just we have seen that L1 t minus 1. But Young's modulus, what is Young's modulus and what is its dimension? So Young's modulus is nothing but simply stress by strain. Stress is nothing but like simply pressure. Strain is not having any dimension. So Young's modulus dimension equal to pressure dimension, or simply you can write force by area. Force by area, right? See, force M1 L1 T minus 2 by area L2. That means M1 L minus 1 T minus 2. This is the dimension of Young's modulus, right? Yes, what they mention, simply what you can, the equation you can write, y is directly proportional to g power x, h power y, and c power z. C power z. See, we can put and simplify. Easy question, na? I'm expecting you can solve. Yeah, you try to solve. Yes, g power x, g value. Uh, y is directly proportional to g power x, L power y, c power z. Y dimension m1 L minus 1 t minus 2, and g m minus 1 L cube t minus 2 whole power x, and h m1 L2 t minus 1 whole power y, L1 t minus 1 whole power z, right? Yes. So, yeah, the task from for you only. Let's simplify the equation and comment x, y, z values. Okay? Yeah. So, yeah, I hope you can able to solve. If you are not solved, we will I'll just disclose the answer and explanation in the next video. Thank you, and subscribe the video Mana Physics Guru channel. Thank you.